Hi, everyone. I am Srijan Kumar. I'm a computer science professor at GeorgiaTech, and I'll be talking about why people fall for hoaxes. We have spent the entire of today looking at what misinformation is, what disinformation is, and how it spreads in the network, and what we can do to protect against those. So one key question that I want to raise is, why do people fall for hoaxes, and how can machine learning help? Before I dive into that, I want to give a brief overview of what my research looks like. And I believe that to solve the problem of misinformation and to solve the epistemic problems that are there on the internet, we need to take a holistic overview of both the false information and the users, the actors that are creating the false information, which are the malicious actors. So over the past few years, over the past 5-6 years, I've been studying both these different topics, and I'll start with looking at Wikipedia hoaxes. So disinformation is very, very popular these days, and primarily so on social media platforms. But Wikipedia itself is not, it is also susceptible to hoaxes. And to give a couple of examples, this is one of the longest running hoaxes on Wikipedia named Jared Owens. It's about an Australian Aboriginal god who has mystical powers and will punish you if you do something wrong. And this hoax article on Wikipedia lasted for about more than 10 years, if I remember correctly. And this is another one, Balboa Creole French. So this hoax article is about a language completely fabricated that is spoken only in an island in California. And linguists actually went to that island to study that language, only to find that it doesn't really exist, and all of their NSF-funded money was wasted. So these are two funny examples as such, but overall, there are thousands and thousands of hoaxes on Wikipedia that have real-world impact. So we wanted to understand we wanted to answer one very key, crucial question of why should we even care about hoaxes, or why should we even care about misinformation that's there on Wikipedia? Because if humans are good at identifying this false information, then we don't really need to worry about it. So what we did was we took 64 publicly known and debunked hoaxes on Wikipedia, paired those with actual legit articles that had similar properties, and we showed them to Mechanical Turkers. So we hired people from Amazon Mechanical Turk, and what we did was we showed them two articles. We showed them a hoax article and a non-hoax article. We didn't tell them which one was which, but their job was to identify the hoax article from the two articles. So let's have a quick game here. So I'll show you two articles, similar to the ones that we showed to the Mechanical Turkers, and let's see if you are able to identify which one is a hoax. So this is Olimar the Wonder Cat. Let me zoom in a bit. So it's about a short-lived children's TV program in BBC in the 1970s. So it has two series. The article looks fine with with an image and all that, with some explanation. And then there's another one. It's called ocular cytosis. It's about a common infection in the eye. So how many people, I know that I haven't given you too much time to figure out which one is true and which one is false, but among the two, which one do you think, raise your hand if you think that the first one is a hoax. Raise your hand if you think the second one is a hoax. Okay. Anyone who raised their hand is a winner because both of these articles are hoaxes. So it's not really, just by looking at the articles, it's really hard to say whether something is hoax or not. So that's what we found with humans as well. With this large study that we did, if you were randomly guessing between the two, you'd get 50% accuracy. And humans were only slightly better, with about 66% accuracy in identifying the hoax article. So essentially, 1/3 of the time, they were wrong. And machine learning classifiers, which I'll go into the details of in the next few slides, can get 86% accuracy, which is much, much higher than what humans alone can get. So here we are not trying to replace humans. Here we are trying to augment the capabilities of humans to understand and debunk hoaxes. And when we looked at what mistakes people were making, essentially when they were thinking that a hoax article is a non-hoax article, what we found was people primarily give a lot of importance to how the article appears or how the article looks like, instead of the actual content. So essentially what that means is accurate detection needs to go beyond how the article looks like and needs to go look at what other features there are. So to understand at a large scale how hoaxes appear on Wikipedia, we look at hoax. There are distinctions between how hoaxes can be in Wikipedia. One is as an entirely fabricated article, or it can be as facts that are inserted, hoax facts that are inserted in genuine articles. So what we did was we primarily studied the first one, because on Wikipedia there's a very clean ground truth of more than 21,000 hoax articles that were manually verified and removed after a very extensive discussion process. So whenever such an article is identified, this particular tag called the hoax tag is put on the Wikipedia article, and then there's a lot of discussion whether the article deserves deletion or not. And after a lot of that discussion, an article is deleted. So we studied these 21,000 hoax articles that were verified to be false and deleted from Wikipedia, and we compared their properties to the rest of the articles on the Wikipedia. So it's like more than a million articles, more than a few million articles that are there on Wikipedia. And we wanted to answer three crucial questions. The first is, what is the impact of these hoaxes? What are the properties of these hoaxes? And how can we detect hoaxes? So let's start with the first one, how impactful hoaxes are, and how can we even quantify their impact? Jimmy Wales, who is the founder of Wikipedia, once said on some platform that the worst hoaxes are those which last for a very long time, receive significant traffic, and are relied upon by credible news media. And what we did was we quantified the impact of hoax articles across all of these three dimensions. And what we found was very interesting and also very reflective of what happens in the real world. What we found was that most hoaxes were caught very, very soon, so they didn't meet the first criteria over here. But about 1% of the hoaxes lasted for a very long time, received more eyeballs than a general article, and were even cited by news agencies, and some even made it into books. So some of these hoax articles are the most damaging ones that we want to worry about. Now that we know that some articles are bad, we want to understand what are their properties. And we essentially characterize the properties of hoaxes across three major dimensions. The first one is how the article looks like. This is primarily important because this is what fools people when they're casually reading, as we just explained in the human experiment with the mechanical Turks that we did. So first we look at how the article looks like. The second, we go deeper. We want to go beyond what the article looks like. So we look at how the article links to other Wikipedia articles, and how the article links to other web sources or the other references that it has. And finally, we want to look at the people who are actually creating these articles. What are their properties? So starting with the first one, what we do is we quantify the properties of these hoax articles and compare with the properties of non-hoax articles along three different features. So we look at what their length is. What is their length compared to the metadata that they have? So in Wikipedia, you have like all this metadata, like the boxes and so on and so forth, and images. So what is the ratio between the plain text, the content, versus the metadata? And how many links per word are there in the article itself? And what we found was somewhat counterintuitive. Like, I would not have guessed that. What we found was hoax articles are not shorter, but indeed longer than genuine articles. But they mostly have plain text and have fewer web and wiki other Wikipedia links as compared to genuine articles. So what it means, my interpretation of this, is that hoax articles are longer because hoaxsters want to put in as much information as they can to essentially show that, hey, this content has a lot of value. But they don't have enough references to essentially cite those. So that's why they have fewer web link and Wikipedia links. So now we look at the link network structure and how the article looks like. And this is how the network looks like. And this is something that you and I cannot actually calculate when we are casually reading. So we look at machine learning and we look at basic computer science methods for here, which I'll briefly explain. So let's say we have this red dot representing an article, and it links to 3 other Wikipedia articles in its entire body. Now, if these Wikipedia articles don't link to one another, we calculate essentially what is called a clustering coefficient, essentially calculating how many links are there between the outgoing neighbors, divided by how many maximum possible links are there. So if there are no links, then the clustering coefficient is 0. And what we can say is that the links that are put in the Wikipedia article are just for the sake of putting references, and the links are incoherent. While if these articles do link to one another, then that means there's some relation between the articles that are linked, and then the clustering coefficient is greater than 0, which indicates a more coherently written article. And what we find is that comparing clustering coefficient, legitimate articles tend to have significantly higher clustering coefficient as compared to the hoaxes that have lived for a very, very long time. So combining these two, so the result from appearance and result from the network structure, what we find is that hoax articles, when they have references, they put the references just for the sake of appearing to be a normal article, but they have less meaning. So they're incoherent references that are being put. And finally, when we look at the people who are creating these articles, in terms of their age on the platform and number of prior contributions, as you can expect, what we find is that hoaxsters are more recent accounts and have very few contributions in the past. So now we have looked at 2 aspects of hoaxes. We have found that very few hoaxes, 1% of the hoaxes have a lot of impact, and hoaxes and non-hoaxes have very different characteristics, primarily in their network. So finally, we look at, can we detect hoaxes? And the answer is yes. And this is one plot that essentially summarizes that. So the key question we want to answer is, given an article, is it true or false? Is it a hoax? So this is what we call a binary classification task. And we compute AUC metric, which is, I'm not going into the details, but it's a metric that goes between 0 and 1. The higher is better. 1 is for a perfect classifier. And what we find is that across 4 different categories of features, so we looked at appearance features, editor features, and network features. And when we combine all of these, we get what I call a all feature. Appearance features alone get 0.7 AUC, which is decent, much better than random. Editor features, so looking at who created this article, gets you 0.82. But looking at network alone gets you 0.88, so much better than just the appearance or just looking at editor. But the most advantage we have is when we have all features combined, which gets almost perfect AUROC. Now, this is great for writing a paper, but what we did was we went a step beyond. We used this algorithm and ran it on entire Wikipedia, and we found articles that our algorithm thought or suspected as hoaxes, and some of these articles were indeed confirmed to be hoaxes and removed from Wikipedia. So this is one of those articles that lasted for almost 7 years on Wikipedia without getting detected. And this is about an American popcorn entrepreneur named Steve Myrtle, who invented some kind of new popcorn and became a millionaire back in like 1970s or something. So this was an article that stayed for a very long time, had a lot of impact, but it did not, but essentially our algorithm was able to identify that. Okay, so I've just spoken about hoax articles, hoax information that's there on Wikipedia, and I want to just briefly talk about people who are spreading these hoaxes, people who are using multiple accounts on social media to deceive others. The technical term for that is sock puppets. So we wanted to study that because this is a very up-and-coming problem. I mean, when we studied that back in 2016, when the paper got out in 2017. So it was a big problem back then, and it has only grown. So what we did was we looked at comments that are being made in the discussion section of a lot of different platforms. So we looked at comments that are being made in the discussion of news platforms, sports platforms, gaming platforms, and so on. In total, we looked at comments that are being made by 2.9 million users, over 2.1 million articles, and the number of comments that they make is 62 million. And the key question that we want to answer there was, are two accounts that pretend to be different users, do they belong to the same person? And in answering that, one important thing that we wanted to understand was, do multiple accounts that a person creates to deceive others, do they always support one another? Now, that's a very reasonable hypothesis, that if you create multiple accounts, you would create them and support one another so that you believe that the discussion, a lot of people believe in that one. So we did a lot of linguistic analysis without going into much detail. We did a lot of linguistic analysis, and let's say I create two accounts, one named Srijan and the other named The Real Batman. And with the first account, I write, this is the best advice ever to a particular article. My second account can go and support that particular comment. And we find that this is only true about 30% of the time. Most of the time, though, the second account doesn't explicitly support the first account. They are primarily being neutral towards the second account. And very few of the cases, surprisingly non-trivial number of cases, 10% of the times, the second account actually goes and opposes the first account, trying to create more discussion around that and trying to seem to have trying to have their feet in both the sides of the conversation. So this was something that we found very counterintuitive, but has since been validated in other studies that have followed up on other social media platforms as well, including Russian bot and troll accounts that were essentially in both camps of the discussion. And finally, as always, being a computer scientist, we create prediction algorithms. So we did that. We asked the question, do two accounts belong to the same person? And when we look at linguistics, along the same metric, AUC, we get 0.8. When we look at the network structure of who is talking to whom and who is replying to whom, we get 0.86. And with everything combined, we get 0.91. So with that, I want to conclude. And I talked about why people fall for hoaxes and how we can detect them, and how people who are using multiple different accounts deceive others, and how we can detect those as well. I can take questions if you have any. Yes?
Thank you for finding the hoax article. And I would have thought that a hoax article does not have very many other articles linking to it. Is that similar to what you found in the clustering coefficient claim?
Great question. So we looked at both outlinks, so essentially the links that an article links to, and inlinks. And what we found is very interesting. Smart hoaxsters, what they do is before creating the hoax article, they go plant fake references. So they create these broken hyperlinks to future articles that they're going to create, essentially to show that there is a need for such an article. And then they went and created this article after waiting for some time. This was something that I would have never thought that someone could do, but I guess there are some very creative hoaxsters out there.
That's normal behavior for a real article.
That's also, exactly. So they're trying to imitate that particular behavior. Yes.
My name's Lane Raspberry. I edit Wikipedia. In the example you used of an identified hoax, you showed a popcorn entrepreneur. This doesn't seem like that's going to harm so many people if a popcorn entrepreneur exists. Did you find something that was actually high traffic and used by others?
So we found a few, yes. So this was, somewhat benign. We found other ones that were self-promoting, in the sense they were not politics related or not health related, but they were like about articles about themselves and so on, which were fake actually. I can give you some more examples offline.
Very interesting. Yes, I'd like to see the whole list.
Okay, awesome. Any other questions? Yes, please.
With the software detection, how did you confirm that the identities were?
Oh, so we had so it was a collaboration with this platform called Discuss. It's a plugin that you can put into any website, and then it will allow you to comment. So we got the ground truth from them. Yes.
When you were having humans, decide if it was a hoax article or not, did you tell them to look at the references at all? I noticed we didn't get a good look at those when they were.
So we didn't give them any instructions except that, hey, can you identify which one is a hoax? And that's because we didn't want to bias them towards one particular aspect of the article versus the other. And we wanted to observe like casual reading behavior, so that we didn't also give them like clicking abilities on these articles and so on. So we just wanted to show like the two articles side by side.
They did not have clicking.
No, because we wanted to see, like, let's say if I'm going on Wikipedia and just reading something without, as a casual reader, what will my behavior be? Yes.
Two questions. So sometimes I got approached by marketers of email saying that they're gonna build the Wikipedia bio page for me for some money. Have you seen that kind of hoax in your study?
So that would be something that's called promoted article, right? Many Wikimedians here, right? So that's a promoted article, and that was out of the scope for this. So for example, if someone was to create your article, it would be about you being a professor at Penn State and everything, right? So it would be a real article. So here we looked at hoaxes, articles that are entirely fabricated.
Okay. The second one is for the clustering coefficient study. So if those hoaxers are forming some kind of alliance, they have some kind of farm, and then they link each other, they might avoid your detection, right?
Yes, that's true. Absolutely correct. We didn't observe that, but behavior can evolve, and that is definitely a way to evade the system. Great insight. Yes. Yeah, one last question.
So I was wondering about the Mechanical Turk type thing. Was there any way that you could get feedback from the people who were doing it, and like what if they like found heuristics themselves? Like, do they get any feedback if they make a right choice or not?
No, I mean, they get paid irrespective.
Oh, no, I just mean like when they're doing it, if they know like, oh wow, yeah, I got it right, like I found the
No,
hoax.
we did not give them any
Okay.
feedback. Yeah.
Yeah, that's fine. Thank you.
Okay, cool. Thank you.